Section 3.2, we're going to be graphing linear equations. Okay. All right. In the last section, we talked about solutions of a linear equation, and all of these points right here are solutions to this particular linear equation. So if I plug in -3, 5, -3 plus 2 times 5, and I simplify, -3 plus 10, and 7 is equal to 7. So this point is a solution. If I plug in -1, 4, -1 plus 2 times 4, -1 plus 8, 7 is equal to 7. So this point and this point so far that we've checked, if we try 1, 3, 1 plus 2 times 3, 1 plus 6, 1, 3 is a solution, 3, 2. All of these are solutions to this particular equation. Now, what do you notice about all of these points? All of these points actually line up, right? They're all in a straight line. It turns out, that's not coincidence, by the way. It turns out that every single solution to this particular equation is going to line up with all of the rest of them. So if you look at this point right here, I don't know what this point is, but I know it lines up with the rest of the points, so it has to be a solution to that equation. If I look at this point right here, I don't know what the point is, but I know it has to be a solution because it lines up with all of the rest of them. So it turns out that every single one of these points right here, keep going, all of these points are solutions to that particular equation. To save ourselves some time, rather than drawing an infinite number of points, that's an awful lot of points to be drawing, rather than drawing a whole bunch of points, we just draw a line and we put arrows on the end to indicate that the line keeps on going. And this line represents, it's a picture of all of the solutions to this particular equation. Notice that the points in the previous graph all appear to lie in a straight line. Every point on the line represents a solution of the equation x plus 2y is equal to 7, and every solution of the equation corresponds to a point on the line. The line gives us a picture of all of the solutions of this equation. We only draw a portion of the line, but it does extend in both directions because we put arrows on either end. So here is the graph of this particular, I don't remember what it was, x plus 2y is equal to 7, okay? Now, this is important, a graph of a linear equation. The graph of any linear equation in two variables is going to be a straight line. I like to ask this question in my class quite a bit. I ask my students, what does a linear equation graph look like? And it's rare that a student can answer it. But guys, hold on, right here. Root word of linear is line. So if I ask what a linear equation is going to look like, you know it has to be a line because that's the root word of linear. That's what linear means. Okay. We want to graph x plus y is equal to -2. Okay, we need to find 3 solutions to that particular equation. To find 3 solutions, they can be any solutions to this particular equation. we can arbitrarily choose values for x or y, not both at the same time, and substitute them in. This word arbitrarily means, in this circumstance, it means basically it means randomly. There's no rhyme nor reason. There's no specific, we have to choose this x value or we have to choose this particular y value to plug in. That being said, 0 is the easiest value to plug into any equation. So what we're going to do is we're going to choose x equals 0 to find one solution. And then we're also going to choose y equals 0 to find a different solution. I did say you have to have three ordered pairs, 3 solutions. So we're just going to let x equals 1. For that one, the smaller the number, the easier it is to plug in. So we're going to draw an XY chart, and we're going to plug in x equals 0. We're going to plug in y equals 0, and we're going to plug in x equals 1. So if I plug in x equals 0, it's helpful if you can do these in your head, but if not, that's fine. We get y is equal to -2. If I plug in y equals 0, x plus 0 is equal to -2. So this time x is equal to -2. And if I plug in x equals 1, I subtract 1 and I get y is equal to -3. All right, so I'm going to take these 3 ordered pairs, these 3 solutions, I'm going to plot them, and then I'm going to connect them with a straight line. So 0, -2, over 0, down 2, left 2, up 0, and right 1, down 3. Now, the reason why we choose 3 points instead of 2, technically, in order to draw a line, we only need 2 points, but we do 3 because that is a way of checking our answer, basically. If the 3 points did not line up, that tells us we did something wrong, so we have to go back and check our work. All right, we're going to do the same thing. We're going to let x equal 0. We're going to let y equal 0. This time we're going to let x equal -4. The reason why the textbook authors chose -4 was so that they would end up with a nice integer for y, but you don't necessarily know that when you're doing it. So I would pick x equals 1 or x equals -1. You're probably going to end up with a fraction. That's okay. They chose -4, but you are not going to know ahead of time what number to plug in to avoid fractions for this equation. So just pick any random number that you like. We're going to plug in x equals 0. And remember, anything times 0 is 0. So 2y is equal to -10, or y is equal to -5. So this gives me the ordered pair 0, -5. And this time we're plugging in y equals 0. Two times 0 is 0. And we divide by 5. And we get -2 for our x. And then we're going to plug in x equals -4. So we have 5 times -4. Multiply. We are going to add 20 to both sides. Remember, if the signs are opposite, we're going to subtract the numbers and take the sign of the bigger one. Divide by 2. And we have the point -4, 5. So we're going to plot these 3 points. Plot these 3 points, 0, -5, -2, 0. negative 4, 5, which is way up here. And my line is probably not going to be straight. It's really hard to draw a straight line. Hey, I did a pretty good job. All right, so there is this, there's the graph of that particular linear equation. Okay, what we've been doing, remember how I said plugging in x equals 0 is a good thing to do and plugging in y equals 0 is a good thing to do? Well, actually, this happens so much in math that they have actually named that concept. If we look at, we're going to look at the previous example right here. So we have this point, negative 2, 0, and this is where the graph crosses the x-axis. So I want you to pay particular attention. When I cross the x-axis, doesn't matter where I cross the x-axis, but where I cross the x-axis, I'm going to have a number for an x value, and I'm going to have 0 for a y value because it's on the x-axis. So if you look on the x-axis, we're not going up or down at all whatsoever. So my y value will always be 0 anywhere on this x-axis. My y value is going to be 0. So this would be the 0.30. This would be the 0.40. This would be the 0.3 0. This would be the -1, 0. Every point on the x-axis is going to have a y value of 0. Okay, that's important. You need to know that. We're going to have a number for x, and the y is going to be 0. In the same way, if we look at this point right here, 0, -5, this is exactly the opposite. So this time, I'm not going left or right at all. So my x value is going to be 0 this time, and I'm going to have a number for the y value. It doesn't matter where the graph crosses the y-axis, my x is always going to be 0, and I'm always going to have a number for the y. Important to remember. The graph intersects, crosses the x-axis at -2, 0, and the y-axis at 0, -5. So this, where it crosses the x-axis, is called the x-intercept, and this, where it crosses the y-axis, is called the y-intercept. Intercepts, this is important, intercepts are often convenient points to use when graphing linear equations, okay? Very, 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 very convenient to know where the x-intercept is and the y-intercept is. Partly because you're plugging in 0, so it makes it just super easy to find those points. All right, so make sure you write this down. This is super, 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 super important. Where we cross the y-axis is called the y-intercept, and it's always going to have a 0 for an x and some value for the y. And where we cross the x-axis, we call that the x-intercept. It's going to have an x value, and it's going to have a 0 for the y. Okay? To find the x-intercept, we are going to let y equal 0, plug it in, and solve for x, and it's going to be something like this, a number and 0. To find the y-intercept, we do the exact opposite. This time we plug in x equals 0, solve for y, and it's going to look like this. Here's where I bring up one of my pet peeves, and I know that teachers do it, I know that textbooks do it, I know that whatever, I don't care if you have some other teacher, whatever they decide. But for me, when you tell me the x-intercept, I need an ordered pair, okay? So if I ask for the x-intercept, let's go back to the previous example. If I ask for the x-intercept and you give me x equals -2, and that's it, I will mark it wrong because the x-intercept is not -2. The x-intercept is the point, the ordered pair, -2, 0. Same thing with the y-intercept. If you give me a y-intercept of -5, I will mark it wrong. You need to give me the ordered pair 0, -5. Okay, just a heads up. I'm warning you ahead of time. I don't care what other teachers tell you. For me, if you're in my class, I need to see an ordered pair. All right, so we're going to find the intercepts, which means we're going to start by letting x equal 0, and then we're going to let y equal 0, and then we're going to plug in some other value for x. In this case, we'll choose 4. Again, you're not going to know ahead of time what value to plug in here without getting fractions. So you're just going to have to plug in a number, and you're going to end up with a fraction. I'm sorry. Plug in x equals 0, and when we plug in x equals 0, remember this is our y-intercept. Plug in y equals 0. This is going to give us our x-intercept. So we have 5 times 0 plus 2y is equal to 10. So we have the point 0, 5. This is going to be our y-intercept. And plug in y equals 0. And we get x is equal to 2. And then plug in x equals 4. So 20, subtract, we get -10. And we get y is equal to -5. So 4, -5 will be our third point. All right, so 0, 5, go over 0, up 5, 2, 0, and 4, -5. And again, this is awful steep. And arrows. There you go. Right? Let's do this one. Again, we're trying to find the x-intercept, the y-intercept, and we're going to let x equal 6. Now, one thing I do want to point out, when we have this fraction here, okay, and you're randomly coming up with a value for x, if you remember how you multiply a whole number times a fraction, do you remember? You divide by the bottom and multiply the top, right? As long as we choose an x value that is divisible by 3, then we're going to end up with an integer, with a whole number. So here's my point. If you want to pick a random value for x, that's fine, but I recommend some multiple of 3. So -3 you can plug in. Plug in 0, plug in 3, plug in 6, plug in 9, plug in 12. Any of these would be perfectly acceptable to plug in for x, because you will end up with an integer, and that's always easier to graph. Okay? But we're going to use 6 because that's what they told us to do. So we're going to plug in x equals 0. Remember, this is our y-intercept. And we get y is equal to -2. Plug in y equals 0. This one is going to be a little bit more work to solve, so we're going to add 2. If you recall, if we have a fraction here, what we're going to do is we're going to multiply by the reciprocal. The reciprocal of 2/3 is 3/2. Okay, so these cancel out. 2 goes into 2 one time. 3 times 1 is 3. and we're going to plug in 6. Divide by the bottom, multiply the top. All right, so these are our 3 points that we're going to plot: 0, -2, 3, 0, and 6, 2. Connect them, arrows. If you're like me and you kind of miss one of these points, you just make the point a little bit bigger. All right, I am going to stop stop here for now, and I will pick it up in another video.